Welcome to Cassandra Lunch number 103. Don't forget to like and subscribe as well as turn on the notification bell so that you can get notified every time we post a video or go live. Today we will be covering CICD on the Data Lakehouse with Project Nessie. It will be presented by Alex Dremio. He will discuss this in great detail. The co-organizers for this event are Rahul and myself. If you are interested in being a co-organizer and want to help get speakers by reaching out to people in the Cassandra community around the world, or the larger data engineering community around the world, drop me an email. The marketing email is listed below. You can also email me directly here. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is made up of a lot of different groups centered around data, and you can find out more about all the different groups and events at datacommunitydc.org. What do we cover here at Data Engineers Lunch? We cover all things from the ingress, egress of data, different data sources, data stores, data sinks, and generally all of the ecosystem that surrounds data engineering. If there's anyone new, I would like to say hi, what brought you here, or what you hope to get out of this, drop something in the in the YouTube chat. And please don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. A few group rules. If you have a question, please ask it. I will be monitoring the chat and passing questions along to Alex. Please do be polite and courteous and share what you know. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. Data engineering is absolutely our bread and butter. Thanks to our sponsors, including DataStax and GW University. Thanks to all of our institutional and organizational sponsors. If anybody has job offers, you're looking for a job, please drop links. We're also happy to promote meetups, hackathons, classes, or conferences in the chat. Drop those links as well. We currently host Cassandra Lunch some Thursdays at noon EST. Please reach out to me if you have an idea for a Cassandra Lunch you'd like to present, or generally to learn more about Cassandra. All of our videos are available on YouTube, starting with Cassandra Lunch number 10 and Data Engineers Lunch number 1. Check out those great playlists. And this is a Cassandra runbook that we published here at Anant. I was part of making this. And generally, you can find all of our runbooks at anant.us/runbook, where you can gain a ton of great information. So thank you, everyone, for being here. And thank you, Alex. I'm ready for you to go. I'm going to stop sharing, and please pick it up when you're ready.
Sounds good. Hey, everybody. Welcome once again. I'm glad to be back here on Anant's Data Engineers Lunch. Again, my name is Alex Merced. I'm a developer advocate at Dremio. And again, Dremio is the Data Lakehouse platform. So basic bottom line, if you're running into any thought process regarding implementing a data lakehouse, oftentimes we're going to have some sort of way we can assist you with our platform. So always feel free to reach out, or just, feel free to hit me up or follow me on LinkedIn. But again, I'm a developer advocate here at Dremio. I've worked for many different companies in the data and web spaces, including GenEd Systems, Crossfield Digital, Campus Guard, General Assembly. I'm currently a co-author on the O'Reilly book, Apache Iceberg, The Definitive Guide. So I spend a lot of time thinking and talking about data lakehouses, particularly when using Apache Iceberg. And I've spoken at many different events, Data Day Texas, which I'll be speaking at again next month, OSACon, which I'm actually speaking at again in a couple weeks, P99 Conf, Data Council, and many more. I'm also speaking at Move Data Conference this week. I'll talk about some of the other appearances this week. It's been a busy couple of months. But I just have a profound love for technology, whether web and data. Okay, I host several podcasts, which we'll mention, and I've written several different libraries across different languages. I like code, I like tech, I like talking about architecture and all these fun things. And with that, yeah, so one of the things I'm working on right now is writing this writing this book, Apache Iceberg, the Definitive Guide. And you can get yourself an early release copy by scanning this QR code right there. So that way you can start reading the book now. I mean, the book's just about done. So I think most of that manuscript is there. Right now, we're just kind of polishing off all the chapters. And as we start getting ready for sort of final run for printing next year. You'll be able to actually like get a physical copy. It's gonna be really exciting. I'm excited. And there's a lot of really good information in the book. Also, the host of a lot of podcasts. Again, here are the podcasts. You can subscribe to them on Spotify and iTunes. So if you enjoy listening to me talk about tech, particularly data, these are the podcasts to listen to. Gnarly Data Waves, which is our weekly show over there at Dremio, where we talk about different data lakehouse topics. And then we have 3 podcasts where I just talk about random data topics in the grand schema of things. Had to have it. It was such a great fun. Data Nation, Select Star from Data Lake, all talking about data and just random data topics and random data concepts, just to be sort of an educational outlet. But as I mentioned, I'm doing a lot of events right now, so just so you're aware of some of the other events this week. So this is all this week. Okay. Basically tomorrow, if you enjoy these kind of virtual talks, as part of Gnarly Data Waves, I'm going to be doing a talk on Zero ETL and virtual data marts. I'm also going to be doing that talk as part of the Tampa Bay Data Engineers group on Thursday. So if you can't catch one, catch the other. Same jokes, same stories. On Wednesday, I'll be at the Move Data Conference, which is organized by Airbyte, where I'll be talking about data as code, similar to the topic I'm talking about today. This one's going to be a more long form talk. That'll be a more quicker 10-15 minute talk. And then Thursday, I'm also going to be part of a panel about data management. We're going to just talk about sort of the modern challenges in data management and trends and things like that as part of Insights Jam's solution review panels. So lots of great stuff. This is all this week. You can find all this stuff at dremio.com/events. If you want to kind of find out how to watch any of these events, and generally most events I'm going to be part of will be listed over there at dremio.com/events. But with that, let's get to today's topic. We're talking about a trend that's just sort of growing in the data space, because one of the biggest challenges nowadays is data quality, okay? Because data quality is constantly a challenge. Not just because, we want better data, but it's also because the amount of data we're working with is growing. The speed at which we need to sort of ingest and process and deploy that data is growing. So how do I adopt this scale and still be able to maintain quality? Because often if I don't have good quality data, then my BI dashboards aren't going to give me good insights. If I don't have good quality data, my AI models are going to, not be able to do basic math, all these sorts of things. We need quality data to have sort of quality output from that data, whether we're talking about AI models, BI dashboards, reporting, etc. So basically what's happening is that we're trying to borrow a lot of the practices that are seen for code quality, okay? And this is, so basically instead of DevOps, we're thinking data ops. Instead of, code and code practices, we're thinking data as code. So the idea is we're gonna start treating our data and using processes that are more as if we were treating that data as code. So that's what we mean by data as code, adopting all these sort of DevOps type practices, also oftentimes referred to as data ops. What is the goal of this trend? We're trying to improve communication. Okay, so bottom line is just providing more information so people can know what's going on with the data, because we're less likely to make mistakes if we know what we're working with. We're trying to improve data quality and reliability. Okay, because again, we want to be able to trust the data and be able to move quickly with the data. At the end of the day, it's not just being able to get good data, but to get good data fast so we can move nimbly in today's world that requires us to move nimbly. Automation. If you want to move fast, you're going to need to automate a lot of these steps. Okay, the more manual pieces there are, the longer this takes to get from point A to point B, which means you're not moving nimbly. You're not going to be able to meet the SLAs you need to kind of really get the best value out of those insights and act on them in a timely manner. A rapid iteration. Okay, setting up a process that's sort of easy to improve upon. Okay, schemas changed. I want to be able to kind of adjust this whole infrastructure for when that happens quickly, or if something breaks, I want to be able to fix it and get it fixed quickly and identify the problems quickly. So it's like all these kind of things that allow for rapid iteration. Data delivery, something to make it easy for me to kind of actually make the data available once we've kind of gone through all these sort of curation steps. And then governance and compliance, being able to govern and make sure that we're following compliance rules. So that's what like the goals. So those are the more sort of abstract goals we're trying to meet. And then there's the components, the things we actually implement, okay, to achieve these goals, such as version control, which is going to be a very large part of the discussion today. Okay, because version control allows us to implement. So implementing version control allows us to implement CICD, continuous integration, continuous deployment, which I'll talk more about in the next slide. which also allows us, which is generally going to involve some automated testing. Monitoring is also a great thing to be able to kind of see things along the pipeline and be able to kind of have some sort of visibility on what's going on. Containerization, being able to sort of isolate chunks of our processing so they're not affecting each other directly. And orchestration, being able to control to make sure that everything kind of runs in the right order to get the right results. Okay, so that way everything kind of makes sure that the jobs that it depends on are completed before it begins. So these are sort of like all the different sort of, again, the goals to get better data faster, and then the tools that we use to implement to achieve this sort of data ops, data as code trend. Okay, but again, today we're going to be focusing specifically on the CICD piece, continuous integration, continuous deployment. So what does that mean? So there's 3 words here, right? Continuous integration, deployment. So when we think about integration, we mean when we talk about code, we're thinking about bringing in new code. So I'm saying, hey, I want to add new code to the code base. In data, that just means add new data. Okay, so how can I automate the process of bringing in new code? In this case, automate the process of bringing in new data. Then there's deployment. Okay, so if I'm writing code, I oftentimes will isolate my new code onto a branch. So I'm bringing in the code, but I need to eventually deploy the code. So I need to generally move it over to the main branch, where basically that's where the application is generally published from. So I'll need to do like a merge. And there's a process of making sure that that's done in a safe, reliable way, but still quickly. So we want to be able to bring in new code, in this case, new data, and be able to make that data available to our consumers in sort of an efficient way. And this is where the continuous comes in. That implies automation. We want to automate the bringing in of the data. We want to automate the deployment of the data. So that way it's just continuous. Again, when we think about code, this just happens when I push code up to GitHub and then a bunch of tests run and make sure that the code I just pushed up to my branch is quality. And then later on, I do like a push request and a bunch of other tests run and double check the data double check my code before it merges in with the main branch and then redeploys the code. So there's all these sort of automated steps that get triggered along the way. We want to kind of replicate that same process with data. Tools we can use for this, like what we use in code, were like Git, Jenkins, other things like that would allow us to create not just these events, so like the Git pushes, the Git commits, but then also the automated tests. So again, with code quality, so the importance of code quality, it allowed our applications to run better, because we don't want runtime errors stopping the application when you're mid using it. That's not a great use case, which again means more people use the application, which provides business value. Well, when it comes to data quality, it's going to result in better insights from dashboards and reports. It's going to represent in better output from like things like LLMs, or better decisions being made by AI models and better predictions. Okay. And all of those things lead to business value. So at the end of the day, like the end goal here is always business value. We want to basically either improve the user experience when we're building an application, okay, and improve sort of the actions that can be taken based on the data when we're talking about data. And if we do that, the business improves, because it can make decisions that will improve the bottom line at the end of the day. Okay, so when we talk about code, the idea would be I'd push my code up, it would trigger some tests, and if the tests pass, it would then merge that code into production. Well, when we're talking about data, the idea is I want to be able to write the data, and then I want to be able to audit the data. Okay, run my checks, run my tests. And then when that's ready and that's complete and that's sound, we publish the data. But when we're using sort of data versioning tools, that paradigm goes from write, audit, publish to branch, audit, merge. Okay, same becomes a lot like that code. Okay, where we put our data to a branch, we write the data to a branch, we run all our checks, and then if those checks pass, we will merge it in. Okay. And this, again, is our data as code trend. So again, the benefits of data as code, when we're specifically focusing on the data versioning piece that enables the CI/CD piece, the versioning allows us to isolate data, okay? So we can isolate what's going on with the data. We're able to kind of see different versions of the data, which is going to enable rollbacks, being able to go back to previous times. Also, really great thing about having tools like Nessie, which I'm going to be talking about, is that allows us to also like be able to make our rules regarding governance portable, because you can create access controls to those branches to make sure that only the right people can access the right branches, so no one's accessing inconsistent or incorrect data that shouldn't, or data that's sort of mid curation. Okay, So again, what do I mean? I keep saying data versioning, or I keep saying versioning. What's that? Versioning just means to capture, like for example, if I were to take a photo of myself every day, you ever seen one of those time lapses where you see like the person kind of grow up over time? Okay. They didn't actually just have a camera, just record them for like 50 years. They took snapshots of themselves. But because they took those snapshots, you're able to kind of go back to how they looked like 20 years ago. You would see, oh, like that's how I looked like 20 years ago. Wow, wasn't I a adorable type when I was a toddler? Okay. So bottom line is, when you capture versioning, you're capturing snapshots, and those snapshots allow you to go back in time, see how things were, and understand how things progressed. Okay, so same thing here with your data. We can capture commits. So commits are a snapshot in the world of versioning. So every time we take a picture of how the data has changed, that's where the code has changed, we take a commit. And basically we can create branching versions, almost like multiverse. So if you've seen like Everything Everywhere All at Once, what if you watch that same person grow across 2 different timelines? Well, same thing with versioning for code and data. We can now create branching snapshots and see how that changes over different branching paths of commits. Okay. But the thing you can't do in the multiverse is merge. Okay. If you're familiar with Marvel, that doesn't work out too well in the comic book world. But the idea here is I can have my branching changes of commits, and if I like those commits, if I like those changes, I can go bring those over to my main universe, my main branch. Okay, and that's the benefits of branching and merging. I can, create a label. Like I can actually tag certain snapshots so that way I can get back to them easier. So maybe every time I hit a decade, so when I turn 20, when I turn 30, and soon enough when I'll turn 40, I can create a little name for those photos and label, hey, this is when Alex turned 20, 30. So I can easily go back and take a look at how I was at that age. That's tagging. Okay. So I can go back and query the data as it was with a name at a certain point that I named, or take a look at my code as it is at a certain point that I named. That makes it really easy to replicate those previous points in time. So this whole versioning thing, again, brings several benefits. Isolation. I can isolate changes on a branch. No copy experimentation. When I create a branch, I essentially create a separate environment where I can make changes that doesn't affect the main environment. Okay, but I didn't have to make any copies of the underlying data. So when I do a branch of code, I don't have to duplicate all those lines of code and all the storage. When I do a branch on my data, I'm not duplicating all my data files. I'm just creating a changing path of any changes to future data files, okay, which allows me to have different versions of the data without having to double my storage, okay, which is, really nice, because what do we do a lot of times nowadays? We create staging environments and experimental environments by literally just copying what we have and creating duplicates of our data. We can kind of move away from that using a lot of these new versioning tools. Okay, multi-table transactions. Not only can I isolate changes, but if we're isolating changes specifically like with Nessie, where we do it over at our catalog, I can do transactions across multiple tables at the same time and publish them all simultaneously, which is a pattern we've done in data warehouses. The problem is with data warehouses, I can only use the data warehouse tools. What if I want to do transactions across Spark, Flink, then go do some separate stuff using something like a Great Expectations or Monte Carlo to kind of test my data quality? So I'm working with all these different tools, and I want to be able to publish the changes at the end of all that at the same time. Well, I can do that now, okay? Because again, everything stays isolated until I merge that branch. Rollbacks, I can go roll back to previous commits. Okay, I can't do that with photos, so I can't go back to my 20s and 30s, but with my data, I can. Okay, reproducibility. Okay, again, I can reproduce certain states of time using commits. I can go back to those previous. I can go back to those tagged commits and easily say, hey, let's ask myself a question when I was 20 or 30. In this case, let me query the data as it was at the end of like March 2023. And because of this, I'm able to sort of test the quality of my data, the consistency of my data, and validate my data in these isolated spaces. So that way I'm not making inconsistent data or low quality data or unvalidated data available to my consumers. Okay, the only time I publish the data is when I've gone and done those checks. And then I can do those merges to publish that data. Okay, and again, the way specifically this one open source technology works called the Project Nessie. Now, Project Nessie is a specific technology that allows to do versioning in your data. Specifically, it's for your data lakehouse. Okay, so specifically what Project Nessie does is that it's going to capture versions of Iceberg tables. So if you've chosen to build your data lakehouse with Apache Iceberg, you have this tool available to you that will allow you to do versioning. Okay, and the really cool thing is that it does it in a very lightweight way. It's not capturing changes to every data file you have, or capturing a picture of all your data files. What it does, it snapshots your snapshots, because basically every Iceberg table has a current snapshot, sort of like what is its current sort of file that dictates how that Iceberg table is set up. So every time you change that Iceberg table, that file changes. So essentially what Nessie is doing is keeping a track, a list of all your tables and what that existing metadata file is. And every time you change one of those tables, it captures another snapshot saying, okay, here's the list of tables and here's the list of their metadata file. And you can capture branching chains of these commits in a very sort of, again, a lightweight way that it does allow for high throughput. So when you think of, place times where you might be changing the table pretty frequently, like streaming, this is going to be able to handle that, those frequent changes, because of the way these changes are tracked. They're so lightweight, it doesn't take much to do them very frequently. Okay. Oh, went ahead. Spoilers. Okay. There we go. Okay, so that's what Nessie does. Okay, so Nessie is capturing the snapshots of your table. So you can see here in this first commit, both table A and table B in my catalog point to their first snapshot. Now I plan on ingesting some data. So what I do is I create a branch. I make the change to that data, which creates a new commit. And I see that now table B points to snapshot 2 because that was updated. And if I'm happy with those changes, I can merge, and then back on my main branch, now that's going to match the branch. Okay, they're both pointing to snapshot 2 for table B. Okay, so that's essentially what Project Nessie does. It allows us to kind of capture the listing of all our Iceberg tables, but be able to version the changes to their snapshots. So that way we can capture. So like Iceberg is already tracking snapshots of an individual table. This allows us to track the snapshots of multiple tables across multiple points in time. So basically Nessie adds sort of that more catalog level layer over Iceberg's inherent table level layer of capturing snapshots. So the benefits of using Nessie in particular when it comes to managing your lakehouse is you get catalog level operations. So now you can branch, merge, tag, and roll back at the catalog level. That's different than doing it at the table level, which is something that is built into Iceberg, or at the file level, which is something you can do with a tool called Lakehouse. It allows you to do this at this catalog table level abstraction, which has several benefits. It's open source, so you get the benefit of it being an open source tool, so you can go and run your own Nessie server, and you have complete visibility into the code. You can contribute to the code and customize it to your needs. But what if you don't want to deploy your own Nessie server? There's a cloud managed service with Dremio. So Dremio has this thing called DroArctic. It's just essentially a Nessie catalog that's managed. It's actually built into Dremio Cloud. So when you're using Dremio Cloud, you don't even realize it, that internal catalog that's built into the Dremio query engine is a Nessie catalog and has all the benefits of Nessie, plus some additional benefits like a nice UI and some very nice abilities to audit and manage things more visually that are built into the Dremio platform. Okay, it's cloud agnostic. You can use it with any tool, okay? Azure. So if you were to deploy your own Nessie, where you're storing the data could be on Azure, AWS, Google, etc. Okay, it's storage agnostic. It doesn't care where the data is stored. So again, you can deploy Nessie to any cloud, and you can store the fundamental data anywhere, whether it's object storage, okay? And that's unique versus like Lakehouse, which requires an S3 compatible storage layer. But what if you want to use like Hadoop, use HDFS? Well, then that's not an option. But with Nessie, you can use it on either, okay? So you can actually have your data across multiple locations and be able to manage that, and across different types of storage, or even non-S3 compliant object storage or something like that. Okay, and it has access control and cleanup features. Like Nessie inherently has these features that allow you to kind of create rules of ours accessing individual branches. But then when you're using like the Dremio, you step up and you use the DroArctic managed version of Nessie, there's even additional sort of controls because of Dremio's inherent access controls. So you can make your access control sort of portable. So now, hey, the access controls you have on Dremio become applied when you're on Spark. Okay, so basically only people with these account permissions can only access this data and only this data on this branch, those rules become portable, which is nice because now you're only using one sort of governance layer to do most of your governance management instead of having to like manage data here, there, and everywhere. Okay, not that you still shouldn't have some level of management in all places. Like you still want to manage your access to your individual data files, but the idea is you really want to have sort of a central place that handles most of the governing to most of your individual users, so that way you have a clear picture of who has access to what. Okay, and Nessie kind of helps with that. So I'm going to show you an example of just kind of like how this kind of looks in practice. So imagine like this is sort of your data infrastructure. Again, there's different ways you can kind of set this up, different components you can use, but this is just sort of how we're going to imagine it today. So you're going to have your storage layer, which can be anything, as we mentioned earlier. So it could be like something like Google, AWS, Azure, Parquet, and then you store those data in files like Parquet. And then we're going to have our data management layer, which is going to be, in this case, we're going to use Nessie through its cloud managed outlet of DroArctic. Okay. And the cool thing about using that is not only do I get the power of Nessie, but I'm also going to get automated data management, meaning we're going to be able to automate the compaction of our iceberg tables, automate the expiring of snapshots, things that I would normally have to do myself. Okay, so not only do I get the versioning, but I get the automated maintenance. So basically, all I have to really do is focus on just ingesting my data and then running analytics. Okay, I'm not having to focus on every aspect of data management, and that's the whole point, really, of the Dremio platform, to allow you to focus on getting data in and analyzing it, and not being caught up on all these things like materialized views, cubes, extracts, compaction. A lot of that stuff Dremio sort of kind of abstracts away to make your life easier, on top of just being a super fast query engine. So then we're going to be using Apache Iceberg as our table format. So that's essentially the way, the metadata layer that's on top of our Parquet files that allows tools like Dremio's query engine Sonar to be able to basically communicate with that data as if they were tables. Now, of course, we need to go then access that data. Okay, so there's lots of ways you can access that data from Dremio, whether it's through Dremio's REST API, through Apache Aeroflight, through JDBC, ODBC. But one of the most performant ways you can is going to be Apache Aeroflight, because it's designed to minimize the deserialization, and serialization of the data from row to columnar. So basically, it just moves faster, which means we can pull it faster into our notebooks, whether it's Jupyter notebooks, where we might be using data frame libraries like pandas and polars, or pulling them into a DuckDB relation and running some local ad hoc analytics from DuckDB. Whether we're pulling them into some sort of BI tool like a Power BI or Tableau or Hex or whatever you prefer to use. There's endless possibilities. You can pull that data for whatever your use case is really fast. Okay, so you have a fast query engine that's going to query the data really fast. We're going to move that data to your computer really fast using a table format that enables even further speed benefits. And that's going to stay that way because you have a catalog that's going to continue automatically managing that data for you, so that way it stays fast, okay, in a very fast format like Parquet, that it also, again, enables much more efficient querying. So you have all these layers just enabling speed, so that way you can focus on getting those insights quickly. But again, you're also going to have that versioning that's going to allow you to do CICD. Okay, so in this example, we're going to say, hey, you know what? I want to ingest some data. So here we're just showing you the manual SQL. Okay, but what would happen in practice is you would try to automate a lot of this SQL. You would write the scripts that would send these to Dremio either via its REST API or using a tool like dbt, depending on what you're specifically doing, to kind of automate a lot of this SQL being sent to Dremio. And the cool thing about Nessie, it doesn't just work with Dremio. It works with Spark, it works with Flink, it works with Trino. So you can use multiple tools and take advantage of these branches and take advantage of this pattern. I'm just applying it to Dremio here, but it's not the only tool that works with it. That's the beauty of Nessie. It's portable. And basically here, what I'm doing is I'm creating a branch. So I'm creating a branch called staging. So I'm going to, that way I can ingest my data in my staging branch. Then I'm switching over to that branch using this use branch. And that's another nice thing about Nessie is I can do all of this in SQL. Not one time do I have to leave the world of SQL. That's different than most other platforms. Like if I'm using just native Iceberg tables, not only is it just table only, but there are times where I'm going to have to switch over to Java to do certain things. Although that's gotten a little bit better, but you know, that it's not quite as just SQL all the way. Okay, could you be using Lakefs, but oftentimes like the way you do branching, the branches have to be kind of created externally, and then basically the way you take advantage of the branches is through like sort of the file paths. Here's just SQL. I just say, hey, I'm creating a branch. That's the branch. And then I can just begin creating tables like I normally would. So in this case, I'm going to create, here I'm creating a table because we're going to assume that table already exists. It's just I'm creating the table. Okay. And so I'm creating a table with my staging data. Okay. And then what I'm doing is that table with all my staging data then gets merged into the sales table. Okay. And notice I'm doing this on a branch. The reason being is I'm not 100% sure that once I do this transaction that everything's going to be perfect. Okay, so I want to make sure I run some tests before I go publish that data. So all I did was I created my branch, I brought in my staging data, I merged my stage, I upserted my staging data into the main table. Okay, I can then, while I'm on that branch, run different quality checks like referential integrity. So I'm checking, hey, is the data in the fact tables matching all the references to that data? Okay, to make sure that I'm not making references to any records that don't exist. So I'm checking that out first. And again, if that all passes, then I keep moving forward. Well, let's say it doesn't. I'm going to want to sort of roll back. So rolling back is as simple as this. I'm just doing an alter branch. I'm going to say, hey, that branch shouldn't point to the commit it's currently pointing to. I want it to point to a previous commit. So I would just go into like the commit history, grab the commit ID I need, and then run this alter branch statement that would then move it back and undo, basically undoing any transactions without having to do any backfilling or any having to go like take a look through files and clean them up, because Nessie has something called Nessie GC Cleaner that does all that cleanup work for you. So you just do all your transactions, and then the GC Cleaner can go back and clean up any unneeded files after the fact. So you just focus on that table branch abstraction layer and working with that. And then again, if I have multi-table transactions, so while I'm on that branch, if I need to make changes, like if I need to add a new assistant, if I need to add a new sales record, I can make changes to both tables, but neither change is currently visible to my mainline data consumers who are querying the main branch, because this is still on the branch that I have not merged in yet. So I'm able to do transactions across multiple tables. Okay, and this can happen across multiple users and multiple sessions. Not something you usually can see even in a data warehouse. Usually in a data warehouse, when you do multi-table transactions, it has to be sort of all in one transaction. You do that like whole begin transaction, do this, end transaction. Here you can do lots of transactions over a long period of time and then publish them all at the same time. Okay, there's really lots of flexibility in this pattern. And then once it's all said and done, you can then go back and publish it. Okay, I can say, hey, I want to merge that staging branch into a main in Arctic. So in this case, I'm saying, hey, I want to change to the main branch in my Arctic catalog, because my catalog in this case is named Arctic. Okay, and then I can go back and I can just run if I were to run a count after merging, I should see that they both have identical record counts because now their commits match. They're both pointing to the same commit. Okay, so essentially now all my mainline consumers querying the data will see all those changes because now those changes have been brought over to the main branch, but not until after I did all my auditing and all my checking and made sure that all my tables were updated. Wonderful. But again, it's not, that's integration and deployment, but what about that C part, the continuous, making it automated? Okay, that's important because again, it's the automation that makes this process faster. There's different ways you can do this. Okay, a couple different approaches you can take is you could use something like, let's say you do the original ingestion of the data with Apache Spark or Flink. Okay, you're probably going to maybe ingest that into like an AWS S3 bucket. What you can do is when that data lands, that could trigger like an AWS Lambda that can then make an API call to a custom service you made in a framework like Flask in Python that then sends the appropriate SQL to Dremio and automates the sending of that SQL. So it'll send the SQL saying, hey, let's go take this newly created data, add it to these tables in a branch, let us run these quality checks through these SQL statements, and then assuming all this stuff is successful, then run the merge. And again, all that can be automated through just REST API calls to Dremio. Okay, using a custom service. You could also use an orchestration tool. So any orchestration tool that can send SQL to Dremio. Okay, so like dbt could do some of that for specifically more for like rolling out your semantic layer. but essentially DBT can sort of orchestrate a lot of that sending of SQL to Dremio. There's a DBT integration and other tools. And then you could maintain a table of business rules so you can do those data quality checks. So just create a table that says, okay, hey, this table, these facts should be true. And then you can run SQL to check those business rules against that. Or you can use a tool like Great Expectations to check against your expectations, or Monte Carlo. There's a lot of different ways you can do this, but it can all be automated. So in this case, again, I'm just showing you sort of potential examples. So in this case, when I'm sending that API call over, I'm assuming that I'm sending over like a little summary of the data update in that API call that then the service would then like leverage to do the data quality checks. Again, the exact architecture could be meet your needs, and it can, using a lot of the tools that exist, like in DBT, Great Expectations, Monte Carlo, you can even minimize a lot of that setup as well. But then once it's set up, it just runs. You ingest data, it gets ingested into a branch. Your data quality runs check. If they pass, it merges the branch. And if they don't pass, you can then, what it'll do is you can drop the branch. So that's done, and you can rerun the job onto a new branch. Okay, so I mean, like the branch gets, like a branch name gets generated based on the timestamp. When the job runs again, it's going to generate a new branch with a different name. Okay, and then there's another platform that's actually going to be leveraging Nessie that could even make this front part, the ingestion piece, even easier. Is a platform that's coming called Bauplan. We actually, on Gnarly Data Waves, our weekly Dremio program, we did a episode with the founder of Bauplan. So I think sometime next year that'll start getting into start saying like it's alpha release. So that'll also make this whole story much simpler, where you just ingest the data and then you run your analytics with Dremio, which is pretty cool. But yeah, that's essentially like the story. So again, to summarize, talking about CICD, continuous integration, continuous deployment, which involves sort of, again, ingesting data in a branch, running quality checks, merging that data, publishing it to our main, and we can track those branches using Nessie and then automate around that, allowing us to have that sort of data as code, those data ops type principles applied to our data. Okay, and that story is just getting stronger every day as better integrations are being formed and new tools are being built around it. Nessie is expanding its compatibility with different tools as an open source project. So it's a really awesome project. I highly recommend looking into and trying out. I have a tutorial over there. If you go to dremio.com/blog, there's a tutorial where you can set up Dremio and Nessie all on your laptop from Docker containers and actually see it firsthand, and actually see what it's like to create a branch and just the data on the branch, and just see it firsthand in a nice controlled environment on your laptop. So I highly recommend trying that out. That's at dremio.com/blog. Again, my name is Alex Merced. You can follow me on Twitter at Data Lakehouse. Subscribe to these podcasts on iTunes and Spotify. With that, thank you very much.
Thank you, Alex. I really appreciate you being here. I'm looking at the chat. It looks like there aren't currently any questions, but I was interested in asking you one myself. So you shared that really interesting diagram about sort of the different phases, and I was interested sort of where you saw Nessie fitting. I think it had 5 sort of columns, and the second from the right column. Yeah, that one.
Yeah.
This one. Yeah. How does Nessie fit into this picture?
Essentially, DroArctic is an implementation of Nessie.
Yeah.
So essentially in this layer right here, the only difference is that with DroArctic, you get a few extra data management features. So basically, any tables that you have sort of in that Arctic catalog, you can schedule automatic compaction, automatic expiration, not just the versioning. So Nessie itself brings the ability to do versioning and be able to govern those branches, but then DroArctic builds upon that open source project as a cloud service. So essentially, it would be right here. The only difference is that you'd probably still have to kind of add in a little bit of automating your data management if you use Nessie by itself versus using DroArctic, which has those extra cloud managed features.
Interesting. Okay, thank you. Yeah, I think that diagram really tells a story.
I agree. It just makes it clear that's like, okay, when I use these tools together for these purposes, this achieves sort of like where I'm at. So it's basically, I would sit there and I would create some sort of ingestion pipeline. So I might be using a tool like Cassandra to hold a lot of my data for my application. And then basically I will then go land that data in my data lake storage as iceberg tables, which are being cataloged by my DroArctic catalog. And then the thing is that usually the problem with like Data Lakehouse is that like I still have to go manually maintain and optimize these tables. But with DroArctic, it's just going to continue running those compaction jobs and exploration jobs. So that way those tables are always optimized. So it's almost like I'm using a database where I'm not even thinking about those things. And basically turns your data lake into a database. And then Dremio Sonar becomes sort of that the query piece where you're entering your SQL and your different applications might be accessing your data through there. So essentially you do have this sort of decoupled data warehouse, which is essentially the data lakehouse stream, where you kind of have this deconstructed layer that feels like a data warehouse that has the same sort of ease of use and less having to think about how every little piece works, like it would be when you think of things that are deconstructed. So a little bit more implementation because you have to implement these individual layers. But once it's all implemented, you essentially have a data warehouse that's flexible and modular, that keeps your data under your control instead of moving it into someone else's storage.
And that lets you manage different branches pretty easily for the different layers of your application. We're doing a lot of work right now where we're building dev databases and sort of repopulating them each time. And it sounds like this would be a solution for essentially having the data in this data storage layer, and then the data management layer here would essentially be every time we add a new layer to our CICD, whether we're adding stage or whatever, it's automatically sort of populating the
yeah. So if I have another use case, so like for example, I have someone who wants to test out some AI ML model, and they want to test it, but they want to do some modifications to the data that I don't want as in production, but they want to make those changes. I just create a branch and they make their changes without me having to duplicate the entire data or repopulate a whole new storage. They just make their changes on their branch. They run their ML model against that branch and see how things go. And I'm not worrying about it affecting my production users.
Yeah, that's great.
Yeah, I agree. I'm pretty excited about it. I mean, it's still early days, but again, right now there's a lot of room to start kind of getting hands dirty with it and really seeing how there are people who are using like Dremio Arctic in production and starting to see like that pattern take effect in their and again, not just DroArctic, but Nessie. There's people who are using Nessie in production, who are using it even completely independent of Dremio, and having seen a lot of success with it, and just being able to sort of manage these workflows to better leverage their data lake as their center of sort of data gravity. But yeah, so it definitely serves a purpose in sort of creating your data infrastructure, your data lakehouse infrastructure, to serve your sort of data use cases. Again, this is all more on the data side of things, not necessarily on the operational side of things. So basically for your applications and your distributed applications, if you're talking about like, hey, building like the next Facebook, you're still going to want operational like databases, like your Postgres, your MySQLs, your Cassandras, etc. for those purposes. But when you're then architecting and ingesting and setting up all that data for your analytic use cases, this is a pretty useful pattern.
Thanks. Okay, we do have some other questions now. So first, can you send me the link to the laptop demo and I'll post it in the YouTube chat?
Sure.
And then
I'll do that after.
Sure. And then can you talk more about building good dev/QA environments for pipelines? I found it really painful to maintain representative non-production data when dealing with PII, which makes good CI/CD harder.
Agreed. How would I approach that? Okay, so it depends on what tools you're using. Again, the tools I'm going to be most familiar with is like using Dremio and DroArctic. So if I'm imagining those as my tool sets, Dremio makes it fairly easy to kind of manage the PII situation because it has built in like column and row level masking. So what I would do is that I would essentially, actually let me use Excalidraw for this so I can kind of show the whole picture. So Excalidraw, let's just scroll down for some space here. Okay. So the cool thing about when you're using Dremio, okay, that's square. Let me just make that square a little bit bigger. Okay. So here we have Dremio as sort of like your access layer. Okay, so I might have some tables here. Then I got table B. Okay, and then I decide I want to like join them. And all this can be done through Dremio semantic layer. So you can kind of have it all, this whole sort of layers of views kind of all populated in one place. Table C. Okay, what I can do is I can apply masking. I could apply a masking policy here. So let's say this is the table that has PII in it. I could create a column masking rule here. Okay, from main that masks the PII columns. And that'll be based on user role. So basically, users have a certain role, just won't be able to see the PII data. So when they take a look at this table, or they take a look at any other view that's derived from that table, they're not going to, that column masking rule is going to apply. They're not going to see that PII. If they have the right rule, they will. But then also, then when I want to create that experimental environment, if I were to create a branch of this table set, since it's creating a branch and the table's already kind of at this point, that column masking rule would travel with the branch. So then they would still, when they have that branch environment, they can still manipulate the data, but they're still not going to be able to see the columns that are masked, assuming that their role doesn't allow them to, depending on what the masking rule is. So there's different ways you can do that, but that sort of like comes to mind. So like there's different like layers of what Dremio can do as far as like being able to control access to data. But that's sort of off the top of my head how I would kind of construct that. So if I would first construct my semantic layer, construct sort of like how my data is like logically layered for different access, and see, okay, hey, where are the best places to put those security rules in that chain? But then you can create branches to create the separate environments and let people go hog wild. But those rules are already in place, so they can't touch any data that would be problematic if they did have access to.
Thanks, Alex. Will, I'll keep an eye on the chat. I hope that answers your question. If you have follow-ups, please post them, and we'll dig a little deeper here. Again, thank you, Alex, for this great presentation. Thank you to all of our viewers for joining us here. And we don't currently have any more events scheduled in December. We do have an event scheduled the second Monday in January. The first is New Year's Day, when none of us intend to be working. And, we're looking forward to seeing Alex again on the 8th. Will says that answered his question, so we'll close it here. Alex, thank you so much for your time, and we'll see you next month, next year.
I'll see you next year. You guys have a good one.
You too. Bye-bye. Okay, the stream is ended. If you want to